In this next example, we will demonstrate how to create a semantic distance recommender within the recommendation engine. This recommender, which will extract data from the dbpedia SPARQL endpoint at dbpedia.org. We will output the recommendations into our own triple star again into a repository called dbpedia. The SPARQL query that we created will select a number of properties for entities within the RDF graph of dbpedia. These properties will be the subject's occupations, their date of births, their nationality, and abstract descriptions of those subjects. Those abstracts will be filtered just for English versions. Here we can see testing the query, and in this example we can see that the abstracts can be quite long, but we'll show you how you can take care of this within semantic distance recommenders. Again, we've limited this query just down to 5,000 for the purpose of limiting the time for computation. With this recommendation, we'll utilize cosine similarity. I'll reduce the number of recommendations down to 10 and specify a threshold of 0.5 so that no similarities are computed or stored below 0.5 or 50%. Here we can see that we can apply column modifiers for the columns output from the query. Within the columns modifiers drop-down, we can see that the SPARQL query has been analyzed and will automatically update the columns within the drop-down. Within the column modifiers, we can select a number of modifications or filters to the particular columns. In this case, nationality has been set with the weight of 2. We can set the abstract to be tokenized since it is a large amount of text, making sure to save this modifier, and we can set the occupation to have a weight of 3. The weighting ensures that these particular columns take more precedence over other columns when computing similarities. Once we're complete, we hit save, and we can start the recommendation. Again, we'll skip forward to the output of the recommendation. Here you can see it took about 3 minutes to compute 22,000 plus recommendations. These recommendations are as well output to the triple store into their own graph with the same name as the recommender itself. And here again, just like collaborative filters, we can see the recommendations produced as RDF triples within the triple store. Again, we can use the REST API's user interface to query recommendations for particular subjects or items, in this case resources from dbpedia.org. So here we'll just select a random resource and find a number of other resources from dbpedia that have similarities to this one. We'll open these two resources up to see how they might be similar. In this case, 75 or 76% similar. And we can see that these two subjects, based on their abstract and occupation, are probably most likely similar due to the fact that they were both painters or had occupations classified as painting. Other features most likely went into the consideration for the similarity computation. So now with the recommendation complete and the results available through the Recommender API or the triple store, what you can do is you can also reset the recommender if you plan on changing the configuration Once the recommender has been reset, the results are removed from the actual triple store.